This presentation is about the strength that comes in bridging the performance gap by combining human performance technology and augmented reality. Human performance technology is a systematic way of analyzing the performance gap between the current performance and the desired performance in an organization. The organization can be a business, a religious institution, a for-profit or nonprofit institution, or educational. If there is a performance gap, HPT can find the gap, determine the cause, and design and implement a way to bridge the gap. According to Kang and Melinda, HPT practitioners focus on 5 key attributes to ensure successful implementation of bridging the performance gap. The first attribute is systemic. This means that HPT practitioners look at all causes of the performance gap. This includes the workers and individual organizations of the company, directions or manuals given. The first idea of human performance technology is to find the actual cause of the performance gap instead of just creating a training. The second HPT attribute is systematic. There is a step-by-step process to be followed to determine the performance gap, determine the cause of the performance gap, and to determine and implement solutions. Third, only evidence-based practices should be used. According to Ament and Conley, using evidence-based practices influences the quality of deliverables and impacts the policies and funding surrounding the proposed practices. Fourth, the solution should be as cost-effective as possible without compromising the quality of the solution. Lastly, all solutions should be ethical. There should always be a level of excellence desired. People should take responsibility for their own actions, and all behaviors, words, and writings should be kind and respectful. Robin Castro defined educational technology as all technology designed, created, and applied to the education process. Education includes any organization that has trainings and lessons. Hackman and Reindl said that educational technology is the driving force to improve and advance educational outcomes. One way technology improves and advances educational outcomes is by increasing learner engagement. The technology can be used for instant access to information and resources, individualized education, mastery of skills, and self-paced learning. Today, people are connected to technology in an ecosystem called the Internet of Things, or IoT. An example of this are light bulbs, dishwashers, thermostats, washing machines, a watch, Alexa, Google Nest, a Ring doorbell, ovens, anything that can be connected and controlled from a phone or other device, such as an Alexa or a Google Nest. Harnessing the power of the IoT engages the learners for advancing educational outcomes. A technology that is growing in education is augmented reality. Before we discuss this, we need to become acquainted with virtual reality, augmented reality, and mixed reality. Diana Carl gives a great explanation of the three. Virtual reality takes the user out of the real world to a different place. Carl used the example of the holodeck on the USS Enterprise in Star Trek: The Next Generation. It is an example of VR that transports you from your physical environment into a world designed by software and hardware. Augmented reality overlays information in the current environment with other elements to help make decisions. Examples of this would be Google Maps or Google Translate. Google Translate allows the user to scan or input information in one language to immediately have it translated into another language. I used Google Translate in 1 year of teaching with a student who came from Argentina, did not speak any Spanish, or any English, excuse me. I do not speak any Spanish, and so our communications for the first couple of weeks came through Google Translate. Mixed reality combines virtual and augmented reality. Pokemon Go is an example of this. The Pokemon world is virtual reality. Following the Pokemon through the maps of surrounding areas is the augmented reality. Together, they form a mixed reality. For this presentation, we are focusing on the augmented reality. Augmented reality is routinely used with leisure activities we do on our phones or tablets or watches. According to Google for Education report on emerging trends in education, by 2022, an estimated 2 billion mobile users would use augmented reality each month. We do not have numbers on this yet, but it is a very real possibility. The best experience is direct experience, but according to Song and Kid, simulated AR experiences that mimic the real world as close as possible can save money and lives. Flight simulators are some of the first AR used. Pilots are put in different flying conditions, then given information to make correct decisions in the takeoff, flying, and landing of the plane. With AR being such a benefit in the aviation field, it is no wonder other industries are using AR for trainings and skill building. Augmented reality is being used in healthcare, engineering, education, construction, and architecture with great success. It is also being used in many other industries worldwide. Mechanics can use a device that can read digital images. The mechanics can scan the car to find the problems, find the parts needed, and then fix the car's problems. AR can also be used to fill a need for skilled workers. A company low on skilled workers could use AR for those who are unskilled to follow directions correctly. If the AR program is correct, they could follow the steps as shown in this picture, where it gives you that it's step 3 and the direction and what the part looks like and how to unscrew it, and tells you to remove it. And then it goes through each of the steps for each part. While doing this, if there's an error, the software would alert the worker to the error and show or tell the worker how to fix it. Now, just because the AR program is available does not mean that it is a good program. The buyer or the user of the AR program needs to look at the augmented reality fidelity, or the similarities between the simulation and the real world it mimics. The first fidelity is perceptual fidelity, which is how much the simulation visually resembles the system it is modeling. So if it is modeling a heart, does it look like a heart, or does it look like the shape of a heart that we draw? The second fidelity is manipulative fidelity. How do the actions in the simulation mimic the actions used in the real world? Last fidelity is functional fidelity. How well does the model resemble the underlying rules governing the behavior in the real world? For example, do Newton's laws of motion behave the same in the simulation as they do in the real world? If the three of these fidelities all fit together, then you have a good AR program. Human performance technology practitioners are using augmented reality in their designs. They are doing this because learners are in a real-world place, but they're able to build their strength and skills in a safe environment. The HPT model is a systematic way to determine and fix the performance gap. A study by Asgar combined the HPT model and augmented reality to find the performance gap among 3 employees of AZ Electronics who provide on-site computer maintenance and support. The first step is performance analysis. Through the data analysis, the researcher found the current performance, which was too much time was spent trying to find the homes of clients. The desired performance was to find the homes quickly and efficiently. The second step in the HPT model is a cause analysis. The causes in this case were threefold. The 3 employees were using apps on their phones that did not work well, or they used outdated paper maps, and they had to spend time looking for slips of paper with the customers' addresses on them. This was neither quick nor efficient. The third step is the design phase. The researcher determined to use augmented reality tools to solve the problem. The tools included their cell phones and the GPS software developed by PhoneNav. The implementation phase is next. The employees had to download the app on their phones and set up their login accounts. They were then able to enter the customer addresses into the phone and follow the map and directions given, making it quick and efficient. Through the final step, evaluation, the researcher found all 3 employees getting to their appointments efficiently with multiple possible routes to take for the quickest way. The employees also found the app easy to use, which engaged them in wanting to use it more. In the end, as the employees used the GPS, the desired performance increased, essentially building a bridge across the performance gap. Nagabai et al. Showed the effect AR has on learners as they discussed a training conducted to evaluate the long-term effect of AR safety training compared to the traditional training approach. The researchers developed a training strategy that showed simulated construction accidents, the causation of the accidents, hazard identification, and how to control the hazard effectively. After the training, those using AR technology could identify the hazards, the cause of the hazards, and how to control the hazard at a higher rate than those who had the traditional training. Many other success stories are available from many industries, all looking for effective ways to close the performance gap. With success found globally using augmented reality, human performance technology experts should incorporate these technologies into their performance gap solutions. After all, people use AR when they use their smartphones, watches, GPS, tablets, desktop and laptop computers, and many other technologies daily. Harnessing the available tools, creating new tools or software programs as needed, and implementing them into businesses will bridge the performance gap.